Google CEO Sundar Pichai has termed artificial intelligence as more profound than fire or electricity.
NVIDIA's CEO Jensen Huang calls AI the most powerful technology the world has known. This is the age of AI.
Artificial intelligence is a general-purpose technology that is becoming more powerful by the day and being deployed in all walks of life and work. Within the next 5 years, every job, every function, and every industry will be transformed by the power of AI. Hi, I'm Anil Gupta, Michael Dingman Chair and Professor of Strategy at the Smith School of Business, the University of Maryland at College Park.
And I'm Haiyan Wang, Managing Partner of the China-India Institute.
Join us at LinkedIn Learning, where we start by clarifying what AI is and how it is developed, and then spend a good chunk of the time examining how AI can be deployed to create competitive advantages both on stage and backstage. Join us on this exciting journey. I would like to ask you a question. Have you used AI in the last 24 hours? If your answer is no, let me ask you if you have used face recognition to unlock your smartphone or interact with autocorrect or voice-to-text features. If so, then you're already a regular AI user. We may not realize it, but we are already surrounded by AI. It's in our smartphones. It's in YouTube's recommendation engine. It's in Google search. It's in many of the driver assist features in Tesla cars. It's in many hospitals where AI is starting to help radiologists diagnose MRI images. It's in our policing systems where facial recognition is used increasingly to identify suspects. So, what exactly is artificial intelligence? The key to answering this question lies in first defining the term natural intelligence. That is, intelligence as exhibited by humans and other species. According to the American Psychological Association, intelligence refers to the ability to understand complex ideas, to adapt effectively to the environment, to learn from experience, and to engage in various forms of reasoning. Using this definition as a starting point, we can define AI as a computer system that exhibits these traits to at least some degree. By this definition, it's easy to conclude that a calculator would not qualify as an example of artificial intelligence. While it can do complex calculations, it does not adapt to the environment, and it certainly does not learn from experience. That said, not everybody in the AI community dismisses the calculator as not being an example of very rudimentary AI. Nearly 400 years back, when the French mathematician Blaise Pascal invented the first mechanical calculator, many a journalist ascribed human-like intelligence to this simple machine. After all, what differentiated humans from animals was that humans could calculate, animals couldn't. So, if a machine can calculate, it must be called intelligent. Looking back, if we now conclude that no, a calculator is certainly not intelligent, it's worth noting that we humans have long suffered from hubris. Once a machine starts doing cognitive tasks as well or better than humans, we have a tendency to denigrate it as merely calculative ability not worthy of being called intelligence. Even today, a small minority of AI scientists dismiss facial recognition, natural language understanding, and driver assist features as not really true AI. To me, such values reflect more the hubris of these scientists than how we should define AI. As may be obvious by now, AI is not a binary black or white concept. That is, a computer system is either AI or not AI. Rather, like human IQ, computer systems also vary in their degree of intelligence. Nearly 15 years back, the accuracy of image recognition systems to classify photos that did or did not include the image of a cat hovered around 50%, no better than tossing a coin. Today, it's in the high 90s. Similarly, almost by the day, AI systems are getting smarter at interpreting MRI scans, understanding and generating speech, and autonomous navigation. Perhaps, in 10 years' time, we would look back and wonder why we ever called present-era systems as AI, similar to how we view calculators today. Present-day AI systems are extremely domain-specific. An AI that is good at facial recognition is useless at understanding speech and vice versa. domain specificity also implies that some types of AI are already far smarter than humans could ever be. For example, playing chess or the Chinese game of Go. On the other hand, in most other domains, humans remain much more intelligent than computer systems. The biggest difference currently between human and artificial intelligence is that human intelligence is multifaceted. The same brain can read, write, speak, calculate, interpret emotions, and do 1,000 other cognitive tasks effortlessly. Even the best AI systems today reflect narrow artificial intelligence. Now, think about the many aspects of your work context that are already or could soon be powered by AI.
We want you to visualize how AI can create value for your company and your customers. Let's look at some of the concrete ways that Google, a company all of us interact with, uses AI to create value for its customers. Even among technology giants, Google stands out as the leader both in developing the AI technology as well as deploying it to power the diversity of its products and services. Of the 1,000 different ways that Google deploys AI, from driverless cars to advertising to YouTube, let me highlight 3 of their latest applications. Let's start with search, Google's oldest service. Google has long deployed AI to make search more relevant to users. Examples include voice search, which enables users to pose queries via speech, and RankBrain, which uses neural networks to increase the relevance of search results. The latest advance is MUM, short for Multitask Unified Model, which was showcased in mid-2021 and represents a step improvement. MUM aims to integrate content and context at a level not achieved so far. Let's say you want to figure out which school is best for your child. The best answer would depend on deep knowledge about your child, your family, the school options available to you, and the specific characteristics of each school. In other words, the best answer requires a deep integration of content and context. Similar to this type of question, MUM's mission is to help people meet many of the fuzzy and complex information needs in their daily lives. The fewer the number of search queries a user needs to make to come up with the best answer, the better it is for him or her. As another example, take Google's Pixel-branded smartphones. In October 2021, Google launched Pixel 6 and 6 Pro, the latest models. According to reviews, these devices compete well with the best from Apple and Samsung at significantly lower prices. In some important ways, they outdo them in terms of user benefits. The differentiator in these smartphones is the pervasive use of AI. Pixel 6 runs on a custom-built Tensor chip designed to run multiple machine learning models in the device itself instead of in the cloud. As a result, everything in the device, from audio quality to battery usage, becomes smarter and the apps respond faster because information does not need to travel back and forth between the device and the cloud. A new live translate feature enables the user to message back and forth with real-life simultaneous translation without opening a separate app. And there is software that guides cameras to determine the exposure and color balancing much more accurately than any other device, especially for people with darker skin, a first ever feature in a smartphone. Finally, look at Google's foray into drug discovery. In late 2021, Google's parent, Alphabet, launched a new company, Isomorphic Labs, charged with using AI to discover new drugs. Dennis Hassabis, the co-founder and CEO of DeepMind, a Google subsidiary and the company's spearhead for AI research, will also serve as Isomorphic's CEO. In addition to its own research, Isomorphic will utilize DeepMind's AlphaFold technology, which has already demonstrated the ability to predict the structure of nearly every protein in a human body with near-perfect accuracy. Isomorphic also announced that while it will bring AI expertise to the table, it will partner with pharma and biomedical companies to assemble the complementary capabilities needed to discover new treatments and take them through clinical trials and commercialization. Now, think about how you may be able to deploy AI to make your products and services more tailored to each customer's specific context, to add new and better features to them, and to develop entirely new products and services.
The goal of developing an AI tool is to build a machine learning, or ML, model that can take an input, such as a tooth X-ray, and deliver an output, such as whether or not there is a cavity. Training any ML model starts with two inputs: a machine learning algorithm and a data set. Think of the algorithm as a specialized computer program designed to help an ML model learn to do a particular task intelligently. At a macro level, there are three different types of machine learning algorithms, each relevant for certain types of tasks. I use the word type to highlight that there exist many different algorithms within each type. Also, ML engineers keep tweaking their algorithms regularly. Supervised learning refers to those machine learning algorithms where the machine learns from answer keys provided in the training data. For example, in developing an ML model to classify incoming emails as spam, not spam, each email in the training dataset must have a pre-specified label denoting whether it is spam or not. As another example of supervised learning, say you want to develop an ML model to predict the sales impact of increased advertising and or short-term price discounts for a perishable product, such as packaged yogurt. In this case, your training dataset must include real information on the sales impact of previous advertising budgets and price changes. Unsupervised learning refers to those machine learning algorithms that must train the ML model without having an answer key. Instead, the model is trained to identify patterns in available data. Once the model has learned the patterns, it applies this knowledge to provide intelligent answers for new events. As new data emerges, the ML model keeps refreshing itself. Netflix's recommendation engine is a good example of training via unsupervised learning. Each time you open the Netflix app, the company's goal is to present, from top to bottom and from left to right, specific genres and movies that you may like to watch. The faster you're able to locate a movie that you would enjoy watching, the better it is for you and Netflix. The algorithm builds the recommendation engine by making use of everything in the database about your historical viewing choices and mapping them against the choices made by other users whose viewing habits are very similar to yours. Finally, reinforcement learning refers to those machine learning algorithms that must train an ML model to make a sequence of interrelated decisions where the quality of any particular decisions rests fundamentally on future decisions yet to be made. For example, playing a game of chess or driving a car autonomously. From a decision-making lens, such tasks are very different from those which require only one-shot decisions, such as classifying an email as spam, not spam via supervised learning, or recommending a movie via unsupervised learning. Think of an ML model that can play chess intelligently. Whether it takes 20, 30, or 40 moves to play a game of chess, the only thing that matters is whether you win or lose in the end. The score is based on the joint effect of all moves, and it is often impossible to know ex ante whether any single move was a good or a bad one. This is why training an AI to play chess requires a reinforcement learning algorithm. Now, pick 3 or more opportunities in your company where AI can be useful in helping to make better decisions. Think about what type of machine learning algorithm would be relevant for each opportunity. Assume that you work for a nationwide used vehicle retailer and want to train an ML model to take the guesswork out of estimating the market value of used cars. How would you go about it? As the first step, you need to assemble a robust data set containing relevant data on recent transactions in several thousand used cars. Let's say you have good data on close to 10,000 cars. For each transaction, your database should include data on the output variable, that is sales price, and a number of input features. For each car, the features might include make and model, launch year, mileage, color, secondary options such as type of seat, entertainment system, etc., exterior and interior condition, repair history, accident history, and so forth. You would then get the data cleaned up and the various labels and formats standardized across all transactions. Since you already have an answer key in your training dataset, that is, for each car, values of input features and the resulting sales price, it is clear that this context requires a supervised learning algorithm. It would generally be wise for you to pick a few different but pertinent supervised learning algorithms, train an ML model on each algorithm, and then pick the algorithm that beats others in yielding the best model. The next step is to specify several hyperparameters for each algorithm. These are attributes that are specified ex ante to guide the algorithm in carrying out the training task. Some of the critical hyperparameters include a measure of model performance, also called the loss function, that is how accurately the model estimates sales prices when compared with actual sales prices. How the data set should be split between a training set, a validation set, and a test set. Training set refers to data used for training the machine learning model. Validation set refers to data used for measuring the performance of a trained model and to decide how to fine-tune the hyperparameters before running the retraining again. Finally, test set refers to data used to measure and compare the accuracy of the best trained ML model yielded by each of the different algorithms. The number of epochs, that is, the number of times you want the entire training set to go through the ringer to improve the accuracy of the ML model being trained for that particular algorithm. Within each epoch, there often will be a number of iterations, each using a smaller batch from the larger training set. Specify the number of iterations and the batch size for each iteration. The number of hidden layers in the neural network. Hidden layers increase the model's ability to look for complex interrelationships among the various input features that determine the output value. It's the multiplicity of hidden layers that differentiates deep neural networks from shallow neural networks. Once the hyperparameters are specified, you let each algorithm train its ML model. After each round of training, you would use the validation data to measure the accuracy of the model and then fine-tune the hyperparameters, redo the training, measure the accuracy again, and repeat the process until you feel that you have the best possible model for this algorithm. You should thus end up with the best trained ML model from each of the different algorithms. You would then assess and compare the performance of these best models using the test set. After this, you would know which is the best of the best model, and thus the best algorithm. The final step is to decide whether even the best ML model is good enough when compared with human judgment. If it's better, you may make this your primary valuation tool. If it's good enough but not better, you may use it to augment human judgment. But if it's much worse, you may shelve it until better data or better algorithms become available.
Diversity is an innate feature of all natural phenomena, including us humans. We differ from each other by DNA, sex, race, ethnicity, age, nationality, socioeconomic status, family context, friendships, life experiences, you name it. For marketers, a direct implication of diversity is that markets are segmented and that companies should aim to develop tailored strategies for different segments. Marketers have long faced two major hurdles in implementing good segmentation strategies. One, lack of rich data on buyers. Two, very high cost of customization. Developments in information and production technologies have enabled companies to overcome these hurdles to some extent. Today, the rise of AI is pushing the envelope much further towards hyper-segmentation, whereby each buyer and each user could eventually become a segment of one. Let's see how. The majority of adults now have an online presence. While some data is private, much of it is public. Also, companies always have data on every customer they have interacted with. Combining internal with external data can give marketers far richer insights into the peculiarities of every single buyer. Unsupervised machine learning algorithms, such as k-means clustering, can parse through this large, growing, and constantly changing database more precisely than traditional statistical methods. This is how AI-savvy banks and insurers can develop a finely tailored risk profile of each customer, even in those cases where the customer may have no credit history and no hard assets, but does have a social media presence and a network of contacts. This analysis can enable the bank or the insurer to offer interest rates or insurance premia that are more precisely and more richly informed than those from competitors. AI can also help develop more finely tailored marketing campaigns, delivering the right message to the right target audience via the right channels at the right time. Each time you search for something on Google or Amazon, the company learns a bit more about what you want right now in real time. This data goes immediately to work, sending you tailored messages that have proved effective with people most similar to you along a broad array of factors. The likely outcome? Lower cost of customer acquisition. Marketers can also deploy AI's trial and error learning approach. Let's say the goal is to decode what combination of headline, image, copy, colors, and time of delivery of an ad would be most effective for each viewer. Based on past data, the algorithm could begin by serving viewers different combinations with a high probability of success. It would then learn by looking at who clicks on which combination. Through further iterations, it would have refined the segmentation as well as become smarter at serving even more customized messages and formats for each viewer. The root cause behind much of the waste in marketing budgets is knowing only partially or not at all what products or service a potential customer may be ready to buy. Or if they are already inclined to buy something, how to upsell and what to cross-sell. Deploying AI to generate deeper insights into each unique buyer and buying context can significantly increase the return on marketing expenditures. Building on these ideas, you may like to pursue 3 questions. First, what data about your actual and potential customers do you already have within the company? Second, what data exists externally but is currently untapped? Third, how might AI be deployed to parse through this data to enable better segmentation strategies for your company?
AI can drive product innovation in one or both of 2 ways. As an embedded feature of the end product, or as a tool to design and develop the end product. I use the generic term product to refer to both products and services. Let's look at AI as an embedded feature of the end product. The starting point must always be to gain insights into your customers' known as well as hidden needs. Doing so often requires immersion in the customer's world, as well as understanding the needs of their customers. Deep insights will almost always reveal that some needs are being met at best partially and some not at all. The next step is to explore how one or more AI tools, computer vision, natural language processing, complex computational capability, or robotics can be embedded in the product to meet these needs more completely. As an example, take John Deere's See and Spray tractors. In recent years, environmental sustainability has become a growing imperative for farmers. Meeting this goal requires that farmers cut down on the use of chemicals. As the world's leading agricultural machinery company, John Deere has stepped in to help find a solution. The company's answer? Embed computer vision in an attachment to its tractors. As the tractor moves through a farm, an array of higher resolution cameras takes images of whatever is growing underneath. An untrained human eye would have a tough time distinguishing between a crop and a weed. However, a neural network trained through 1 million images, a case of supervised learning, is able to classify a weed from a crop almost flawlessly. The AI then directs automated nozzles to spray herbicides on just the weeds. The end result for the farmer: 80% reduction in the use of herbicides, as well as significant cost savings. Let's now look at AI as a tool for product development. By way of example, consider the challenge of developing small organic molecules. Organic chemists have historically relied on intuition to figure out how to synthesize a desired molecule. The number of possible options, most of which are dead ends, is simply too large to use pure logic to find the right answer. Marvin Segler, a German organic chemist cum AI researcher, decided to tackle this challenge differently. Segler fed the AI system almost all of the known single-step organic chemistry reactions, about 12.4 million in total. He specified the end goal: a specific desired organic molecule. A reinforcement learning algorithm then got to work, using a neural network to discover a multi-step synthesis route and the required starting reagents. The benefits: speed, efficiency, and cost savings. Interestingly, now that Segler has demonstrated what AI can do, it has become possible for chemists to invent new drug molecules not previously thought possible. The opportunities to use AI as a tool for accelerating product innovation are universal. They include making sense of unstructured data for gaining deep insights about customers' needs, as well as exploring a much larger number of possible designs to discover a short list of the best options. Now, think of at least one innovation opportunity of each type within your company. How might you be able to embed some type of AI in one of your products or services to dramatically improve its functionality for the customer? And how might you be able to use AI as a tool to accelerate the next product development or redevelopment initiative? Three major elements of any company's internal operations are designing and building the factory or service center, day-to-day operations, and quality control. Using concrete examples from BMW, DoorDash, and Landing.ai, let's look at how these companies are deploying AI across the three domains. BMW is partnering with NVIDIA to use AI for designing a new drivetrain factory. The partners have deployed NVIDIA's Omniverse software to create a digital twin of the entire factory, enabling managers to see in photorealistic detail how the factory will look and operate. The virtual factory shows all machine tools and workers exactly where they will be stationed. As virtual parts move through the virtual factory, the software even takes into account the effects of gravity, material type, and workers' tools. While factory builders have used simulations for many years, today's digital twins, like BMWs, are radically different in terms of the number of factors they incorporate. This richness of inputs enables engineers to simulate the actual working of the factory at a level much closer to reality. And many of today's AI algorithms simply did not exist even 15 years back. As these algorithms run through millions of cycles to gather training data, they help the engineers understand what's suboptimal and how they might tweak the overall factory design. DoorDash showcases the use of AI in day-to-day operations. DoorDash is a logistics company that enables customers to order and get goods delivered from local merchants. To use DoorDash to order from, say, a restaurant, you log in and choose the restaurant. Once you pick what you want, DoorDash shows you the bill and the estimated delivery time. You check out and wait. How does DoorDash predict the delivery time? The company uses a supervised learning algorithm to train its ML model. Historical training data include the actual delivery time, as well as input details pertaining to each order, the merchant, a timestamp, as well as details pertaining to the neighborhood, such as number of outstanding orders, number of available couriers, day of the week, holiday or not, etc. As new data emerges, the model gets retrained regularly. The goal is to be accurate to the last minute. Overshoot and customers may not order. Undershoot and they may get angry. Behind the scenes, AI also plays a role in DoorDash's logistics engine, balancing supply and demand of couriers, planning optimal routes with changing traffic patterns, and matching couriers to merchants and customers in real time, picking the optimal solution from millions of combinations. Finally, Landing.ai illustrates the use of AI for quality control. Founded by Stanford's Professor Andrew Ng, this company helps clients manage their internal operations. One such client is a steel company that must routinely test for defects in steel sheets. Defects can be problematic in terms of aesthetics, functionality, or both. However, this is not true of all defects. So the key challenge is not merely to identify a defect, but to figure out which is problematic and which not. For AI, this is a supervised learning problem. To train the ML model, Landing.ai has worked with human inspectors to label each type of defect as problematic or not, paying particular attention to accuracy and consistency across different inspectors. Once trained, the machine learning model has proved to be more accurate than the human inspectors. For a large steel mill, even 1% greater accuracy pays off very quickly for the investment in AI. Now, analyze all three aspects of your company's internal operations: designing and building a new factory or service center, day-to-day operations, and quality control. How might you apply AI to improve upon what you currently do?
Opportunities to use AI for smarter human resource management exist in all aspects of the HR value chain: job search platforms, candidate screening, training and development, promotion decisions, even dismissal. Like every technology, AI can also be misused or abused. People may put up with perceived unfairness in many contexts. But if it's their livelihood and sense of self-worth, perceived unfairness can easily lead to tearing the company in the media, lawsuits, or even violence. Companies need to be particularly conscious about using AI for HR in ethical and bias-free ways. Let's start with the use of AI by job search platforms such as LinkedIn and ZipRecruiter. These platforms recommend open positions to individuals and candidates to companies. Nearly always, the platform needs to use natural language processing to decode an individual's credentials on the one hand and job requirements on the other. Consider now the use of AI to screen candidates. Most large employers ask people to apply online. They input always includes resume information, but may also include asynchronous video interviews. Companies can also look at the candidates' social media posts and government databases, such as police records. AI models play a crucial role in screening this information. Natural language processing technology is essential to decode the candidate's application as well as text-based social media postings. In turn, computer vision technology is essential to interpret video interviews as well as images and video posts on social media. There are no ethical issues with using AI to decode the candidate's application and to assess fit with the company's needs. It's also reasonable for companies to analyze government databases to assess risks of criminality or terrorism. However, I contend that it is bad practice to use AI to assess someone's personality from video interviews. Personality is a complex construct. Today's AI is too rudimentary to decode it from video interviews, and most experts view it as no better than trying to extract oil from a snake. Regarding analysis of social media posts, it's a gray area. These posts exist in the public domain, and the content can be analyzed well to assess someone's interests and views, though not their personality. The issue is privacy. Also, some governments require that if asked by a candidate, the company must be able to explain specifically why he or she was rejected. AI is mostly a black box, and saying that my AI did it would not be an acceptable answer to these governments. How about using AI for training and development? Translation systems developed using AI are already very competent across many languages. Companies can use these systems to translate their online training material into multiple languages quickly and inexpensively. AI tools can also be used to assess an individual's grasp of specific materials accurately and to suggest the next module in the program. As a result, people can learn in a more personalized manner. Finally, let's look at how AI is used to decide who to promote. As with screening job applicants, this context also has potential for misuse of AI. Documented cases exist of companies or consultants training AI models on historical data pertaining to who was promoted in the past or not. In the US, such an approach is likely to yield AI models that may disproportionately favor white males, even when others are more qualified. It is an imperative that companies be especially vigilant when using AI to guide them in making promotion decisions. Building on these ideas, I propose the following assignment. Pick 3 different HR processes in your company. How might you deploy AI to manage these processes more intelligently?
AI is a general-purpose technology whose applications cut across all aspects of life and work, and the capabilities of AI are growing rapidly. 2 conclusions emerge from these basic observations. First, over time, we humans will let AI augment many of our decisions. Second, and more interestingly, we will let AI act autonomously in a growing number of contexts without any real-time input from us. Look at the use of AI to screen job applications submitted online. Most HR departments let AI do the screening autonomously without any real-time input from recruiters. Look at Google's use of AI to cool its data centers. Initially, Google used AI to recommend desired actions. Today, it lets AI manage the control systems autonomously. Look also at completely AI-driven hedge funds. Fund managers specify the broad parameters, but then let AI make buy-sell decisions without any real-time input. Projecting ahead to the next few years, AI will clearly become capable of making many more decisions better than humans. In many of these contexts, especially those dealing with serious outcomes, society will be forced to wrestle with moral dilemmas. Without a systematic and thorough resolution of these dilemmas, we will either have chaos or a slowdown in the deployment of AI technologies. Take the case of autonomy in cars. From keeping the car within its lane to self-parking, cars are steadily becoming more autonomous. They're also becoming safer. Yet, every time an autopilot causes a fatality, there is media outcry. In contrast, we hardly ever read about the 36,000 deaths in the US alone annually from accidents caused by humans. Why? The answer lies in research findings that being human, society seems willing to accept human frailties much more readily than errors attributable to machines. Now, imagine that sometime during this decade, cars become fully autonomous and 100% safe in terms of never making any mistake. Purely in terms of saving lives, it's obvious that people should then prefer such cars over driving themselves. Yet, the moral dilemmas will not go away. They may even become more difficult. In a variant of the well-known trolley problem, assume that this is 2027 and you're riding alone in a 100% safe autonomous car. Suddenly, something heavy drops from the truck in front of you. Should the car keep driving and hit the boxes, almost certainly causing great danger to you? Swerve to the right, hit a minivan, endangering 5 people. Or swerve to the left and hit a sedan, endangering only 2 people. What is morally right? Would the answer be any different if you're 25 and all of these 7 other people in their 80s? What if the 2 people in the sedan are in their 20s, but the 5 people in the minivan in their 80s? Whatever choice a human driver made in any of these contexts, we would accept it as just unplanned, spontaneous human reaction. But if the choice is made by a machine, we would treat it as the result of a design decision, deliberately choosing one person's injury over another's. So, if you are one of the engineers designing the car, what heuristics would you build into the AI? As CEO, what guidance would you provide? This is not just an engineering problem, it's a moral question that requires input from not only lawyers and philosophers, but also legislators and regulators acting on behalf of society. Think about the applications of AI in your organization. What moral dilemmas do your company's leaders face today? And what moral dilemmas will they face 5 years from now? When AI models are trained on historical data containing answer keys, there is serious risk that deploying such a model can perpetuate and even amplify past biases. This is not an issue if the AI model is being trained to recognize cats in pictures or detect cancer in MRI scans. However, if the model is being trained to screen job applicants, assess mortgage applicants, or decide who to release on parole, AI models can suffer from embedded historical biases. To illustrate, an August 2021 study found that in the US, lenders using AI models were 80% more likely to reject black applicants than similar white applicants. Engineers training AI models and people from the business side working with them can adopt a number of measures to reduce the risk of perpetuating historical biases. I illustrate some of these here. First, look at the dataset to be used for training an AI model. If it contains too few cases of a population segment, the model's overall accuracy can be high, even though its accuracy for the particular population segment is extremely low. This is why face recognition systems in the US have tended to perform poorly with black faces, especially those of black women. Since most developers are white or Asian males, they have tended to be oblivious to the potential for such bias. Imagine the risk faced by black people when stopped by police who use such systems to check their faces against those of suspected criminals. The way to counter such risk is to assemble the dataset in such a way that it contains large numbers of cases for every relevant population segment, especially those at possible risk of AI-driven biases. Second, use technical fixes to reduce bias in the AI models. One such approach is adversarial debiasing, which uses one AI model to reduce bias in another. Assume that race is the most likely bias-inducing attribute, and an AI model recommends against a particular applicant. The second AI model would take the output of the first model and try to guess, based on all attributes other than race, the applicant's race. If it can do so correctly more often than by chance, then the first model would need to be retuned and the process repeated until the second model can no longer identify the applicant's race. Third, conduct fairness audits before an AI model is released for general use. There are multiple ways to do so. One approach is to use two random subsets of the historical data. In one subset, mask all sensitive attributes, for example, by coding every applicant as a white male. If the AI model yields similar predictions across the two data subsets, then it can be deemed bias-free. Otherwise, you need back-to-square-one measures to mitigate bias. At a broader organizational and societal level, measures to reduce the risks of algorithmic bias include a diverse AI talent pool so that the developers are sensitive to the risks of AI bias, mandatory AI ethics courses in engineering and computer science programs, and even regulatory actions by policymakers. The European Union is one such government actively contemplating regulatory actions, especially in use contexts where the harm caused by biased AI models is likely to be high. For your own organization, I suggest two assignments. First, take an existing AI model in use. How would you conduct a fairness audit on this model? Second, consider the most likely new deployment of AI within the company. How would you ensure that the new AI model would be bias-free? Artificial intelligence is transforming every function in every industry, be it agriculture, banking, healthcare, or transportation.
Here are some of the key takeaways from this course on artificial intelligence and business strategy.
AI can be defined as any computer system that mimics, to at least some degree, natural intelligence exhibited by humans and other species.
The three major approaches to developing AI are supervised learning, unsupervised learning, and reinforcement learning.
Data to AI is like fuel to a fire. The cleaner, richer, and larger the data set on which it is trained, the more accurate your AI model will be.
For market research, AI's biggest impact lies in using the power of natural language processing and computer vision to tap into unstructured data.
AI can help hyper-segmentation strategies where each buyer and each user could eventually become a segment of one.
AI can drive product innovation either as an embedded feature of the end product or as a tool to design and develop the end product.
Leading-edge companies are starting to build digital twins of their supply chains, deploying AI to manage the digital twins and using the output to augment their decisions and actions.
AI can be deployed for smarter management of all aspects of the HR value chain: job search platforms, candidate screening, training and development, promotion decisions, even departures.
Since we are all human, society seems willing to accept human frailties much more readily than errors attributable to machines. This creates moral dilemmas regarding how to deploy AI in contexts where it can affect life or death decisions.
Since AI models are trained on historical data, there is serious risk that deploying such a model can perpetuate and even amplify past biases. You can pursue systematic approaches to mitigate these risks.
Last but not least, AI will affect jobs in three ways. It will augment and alter, but not eliminate, some jobs. It will eliminate the need for some jobs. And it will create entirely new jobs, sometimes in entirely new industries that did not exist before.
We wish you success on the never-ending journey of learning about and deploying AI.